So the next topic is the second derivative test. And here we have a little theorem, but I'm not going to write it as a theorem. I'm going to say that suppose, can I remove the page number 4? Thanks. Okay, so here we go. Suppose f double prime, where am I? Suppose f double prime of x, again, second derivative, is continuous. But here we are satisfied continuous near x equals c. Okay? And we have two things. Let me see if I can use a darker pen. This pen is a little bit, it's fading on me. I guess I need to resupply myself with. Let's see, what color is this? This might be blue. Let's try this pen, okay? So here's what happened. One, if f prime of c equals 0 and f double prime of c is positive, then f of c is a relative maximum, a relative minimum. So here's the two conditions, okay? We want f prime to equal 0 and we want f double prime to be positive. Okay? So then we have relative minimum. We're going to look at it in a minute visually, try to understand this statement. But it's fairly easy to understand once you visualize it. 2, here's another if statement. If f prime of c equals 0 and you can guess f double prime of c is negative, then f of c is a relative maximum. Okay? Now, to understand it, let's go 2 pages ago and look at this little sketch. Okay? Let's look at this sketch in my page 5. It's clearly here we have a relative minimum, right? And notice, for this to be a relative minimum, we need to have the first derivative equals 0. In other words, the slope of the tangent is horizontal. Or the tangent is horizontal, the slope is 0. The slope is 0 means the first derivative equals 0. On the other hand, in the vicinity of this point, the second derivative is positive. In other words, it's concave up. So concavity up tells you that you have a minimum. That is if the first derivative equals 0. Likewise, look at this point right there, which visually we clearly see to be a relative maximum. The tangent is horizontal, the slope of the tangent is 0, therefore the first derivative is 0. The function in this region is concave down, second derivative is negative. So, second derivative negative tells you that you have a relative maximum, second derivative positive tells you that you have the relative minimum, provided that the first derivative equals 0. Okay? So let's look at an example where we test this theorem, which is a theorem f of x equal x to the 4th minus 4x cubed. Okay, we want to find relative extrema using the second derivative test. So first we need to find critical numbers, right? So first let's find critical numbers, or when f prime equals 0. So what is f prime, right? F prime of x equals 4x cubed minus 12x squared, and we want it to equal 0, so we get let's factor out 4x squared and get x minus 3 equals 0. So we have critical numbers are x equals 0 and x equals 3. Okay, so we found out where the first derivative is 0. Now let's find out the second derivative, f double prime of x. We're going to differentiate right here. We don't want to use the product rule. We're going to go here, and we have 12x squared minus 24x. Okay? And now we want to know whether this is positive or negative for, we can factor, let's say, 12x just for the heck of it, and we get x minus 2. Okay? And now we first look at x equals 0. That's where f prime equals 0 one time. So f double prime of 0 equals 12 times 0 times negative 2. Well, it's equal to 0, right? So really we don't know what's going on here. We don't have a theorem for that, because all we have is either f double prime is positive or f double prime is negative. So now let's look at x equals 3, the other point. That's a little bit clearer. F prime or f double prime of 3 equals to 12 times 3 times 3 minus 2. So it's equal to 36, right? It's positive. So we can conclude that we have relative minimum f of 3 is a relative minimum. So this will be the answer. What we take out of this exercise is the following note, okay? And this is what we saw, that the second derivative test does not apply if f double prime of c equals 0, or f double prime of c does not exist or undefined. Okay? So what do we do in this case? Like when x equals 0, right? In this case, where we put a question mark. Any idea what should we do here? Do we have another test that we can use for maximum minimum? Okay, you're quiet, but we have the first derivative test. Remember, we just gone through that. So in this case, we'll use the first derivative test. I need to start giving it acronym, like FDT and SDT. No, SDT doesn't sound right. All right, so let's apply the first derivative test. Okay, the first derivative test, remember, we need to check what happened to the left of 0, what happened to the right of 0. So I want to pick up good, I want to pick up convenient test point. Okay. So we know that f double prime of 0 equals 0. So we need to check what happened to f of x. F prime of x, actually what happened to f prime of x? F prime of x, you recall, is 4x squared times x minus 3. Okay? So we'll take test points or test values. Change that to text values. Actually, time for me to test your fancy, what you might call it, whiteout. Put it to use. I need to talk to our secretary, ask her to bring me one, and she couldn't find. The thing is, it's not tight enough, and it came out. Here we go. Maybe I'm pressing too hard. So, test values. I'll choose, I need on both sides of 0, so I'll choose x equals -1 and x equals +1. Okay, so let's see what happened to f prime at -1. F prime at -1 will be, this is 4x squared, so we have 4 times -1 squared times -1 minus 3. Well, that will be negative, right? Okay, and at +1 we have 4 times 1 squared times 1 minus 3. It's still negative. Okay, so here we are convinced because we don't have change of sign, the function continued to decrease. Okay, so from here we get f of x is decreasing, is d, and here also f of x is decreasing. So turn out that the conclusion x equals 0 is neither a relative max nor a relative min. Okay? So the only conclusion is that we have relative minimum at x equals 3.